Hello everybody. This video is going to be on solving quadratic equations using a neat, slightly modified version of the traditional quadratic formula. So here it is. If x squared equals 2pq plus 2px plus q, then x equals p plus or minus the square root of p squared plus q. Now that seems complicated, but it's really not. So something I want you to pay attention to. One is notice how the x squared is isolated. So that's good. That makes it clear that I'm just going to isolate the x squared term, quadratic term. Second thing is notice how whatever the coefficient, linear coefficient is, 2p, p is just half of that. Notice how q is the constant, and it's right here as well. So let's put those ideas together. Find the roots. X equals half of -6 is -3, because -6 is 2p, so p is just -3. So all you have to do is take half of this to start, plus or minus. This is my p, so what's my p squared? -3 times -3 is 9. And all I do is attach the constant, plus q, so -8. It's that easy. So my answer is -3 plus or minus square root of 1, which we know is just 1. So I have -3 minus 1 is -4, and -3 plus 1 is -2. I'm done. All right, let's go here now. What's half of -14? -7 plus or minus the square root of, this squared is 49, attach the constant 40. So I get -7 plus or minus the square root of 9, which is, we know is 3. So -7 plus minus 3 is -10, and -7 plus 3 is -4. I'm done. All right, let's move here. So I have, what's half of -7? -3.5 plus or minus the square root of, so I want to square this now. I should say x equals. So now I want to square 3.5. Now there's a trick to squaring numbers that end in 5. You just take the first digit, you multiply it by the next number, so it's going to be 4. 3 times 4 is 12, and just attach the 0.25. And then I'm going to attach the constant, which is -12. If you didn't know how to do that, by the way, this little trick I showed you, you can still use a general shortcut. So I have 3, 5, let's worry about the decimal later, times 3, 5. So 5 times 5 is 5, carry the 2. I'm going to go 3 times 5, 3 times 5, using the Vedic method. So 15 plus 15 is 30, plus 2 is 32, so 2, carry the 3. 3 times 3 is 9, plus 3 is 12. And then decimal will go here, because I added here and here. So either way you get that, so -3.5 plus or minus, what does this equal? This is just 0.25. Now, if you think about it, it's not that bad. 0.5 times 0.5 is 0.25. So this has to be -3.5 plus or minus 0.5. So I get -4 and -3. Okay? Let's move on to example 4 now. Now notice how the x squared term is not isolated. So I have to subtract this and add this to both sides. So just an easy trick is, if you want to bring a term over to the other side, just change the sign. So I get x squared equals -1x plus 20. Great. What's half of -1? -0.5 plus or minus the square root of. Now this is just -0.5 times -0.5 is 0.25. Then I have plus 20. So -0.5 plus or minus 20.25. Now, when something ends in 0.25, if it has a perfect square root, it's going to end in 5. So this comes with experience, but I know right away that the square root of 20.25 is 4.5, because 4 times 5 is 20, and then you just attach the 0.25. So -0.5 plus or minus 4.5. So that equals -4, sorry, -5, and it also equals, when I add 4, +4. Okay? All right, last one right here. So notice how the x squared term is not isolated, and I have a coefficient here. So first, let me divide everything by 2, so I get x squared plus 5x minus 24 is 0. Okay, so I'm running out of room, so what I'm going to do is I have x squared equals -5x plus 24. negative 5x plus 24. So I have negative 2.5 plus or minus the square root of 2 times 3 is 6.25 plus 24. So negative 2.5 plus or minus the square root of 30.25. And that's just going to be 5 times 6 is 30, so I know it's 5.5 squared. 5.5 squared is 30.25, so I get negative 2.5 plus or minus 5.5. So that's equal to negative 8, and it's also equal to 3. Okay, so this method's pretty neat, pretty handy. Keep practicing, we'll get better.